Welcome to the Explainer. Today, we are taking on something huge. We're digging into a massive 143-question technical quiz that covers the absolute depths of Angular. And we're going to distill all that raw data into one high-speed, cohesive bootcamp. So whether you're a novice just trying to wrap your head around the architecture or a seasoned developer updating your mental model, this is your roadmap. Okay, let's dive right into this. Here is the agenda we're following today. We've broken the journey down into 6 core pillars. 1, components and decorators. 2, routing and navigation. 3, mastering Angular forms. 4, services and dependency injection. 5, observables and signals. And finally, 6, pipes and optimization.
All right, Pillar 1, components and decorators.
To kick things off, our source material hits on a really fundamental distinction. An Angular component is essentially just a directive that happens to have a template. But how do these components actually interact with the DOM around them? It's a spot where a lot of people trip up. Now, what's really interesting about this slide is the specific question it poses. What is the exact difference between ViewChild and ContentChild? Well, the answer completely comes down to where the element actually lives. ViewChild is querying elements that exist directly inside the component's own template. But ContentChild, that is all about content projection. It's querying elements passed into the component from a parent, usually passing through an ng content tag. You absolutely have to know this difference if you want to safely manipulate your projected templates. Moving beyond querying, decorators are literally your toolkit for controlling how data flows and how elements react. As you can see, @input lets data flow down from a parent to a child, while @output emits custom events right back up. And then there's @hostListener and @hostBinding. These are fantastic because they let you listen to events or bind properties directly on the host element itself. No messy DOM queries required. Okay, Pillar 2, routing and navigation. So once you've got your route routes registered with Router module and you're pulling parameters using activated route, you have to lock them down. Routing isn't just about getting from point A to point B, it's heavily about security and performance. Let's test your knowledge on loading strategies here. Which route guard actually prevents lazy loading? Can activate or can load? This is a vital distinction. Can activate stops an unauthorized user from accessing a component, sure, but the browser actually still downloads the module in the background. Can load, on the flip side, stops the entire ng module from even being delivered. If your goal is to save bandwidth by not fetching unauthorized lazy loaded modules, can load is exactly the guard you need.
Moving right along, Pillar 3, mastering Angular forms.
Getting data from users is pretty much the most critical part of any web app, right? And Angular gives us 2 main ways to handle it: template-driven forms and reactive forms. Template-driven relies on directives like ngModel right there in your HTML. Reactive forms, however, use explicit models that you create programmatically inside the component class. So the crucial point is that reactive forms give you way more control and testability, simply because your logic lives in TypeScript, not hiding in your HTML. To really master reactive forms, you've got to grasp the hierarchy. Think of it like a giant puzzle. At the very top, you have the form group, which tracks the state and validity of a whole group of controls. Inside that, form controls track the individual fields. Need dynamic lists? You use a form array. And finally, you wire the whole shebang up with validators, which are built-in functions like required or min length to make sure your data is perfectly clean. Next up, Pillar 4, services and dependency injection. Let's move to services and see how this builds. To share data across your app without ending up with tightly coupled spaghetti code, you create a service using the @injectable decorator. By setting provided in root, you're telling Angular's root injector to create one single shared instance. And the really cool part? Modern Angular treats these root providers as tree-shakeable, meaning if your app never actually uses the service, the build process literally just drops it. Instant bundle size savings. But what if you need to inject something that isn't a class, like a plain configuration object literal, or even just a primitive string? That is where an injection token comes in. You create the token and then use the useValueProvider configuration to bind that token to your object. It is a brilliantly elegant way to pass environment variables all around your app. All right, Pillar 5, observables and signals. This is where we get into state management, which has seen some massive evolution in Angular. Starting with classic RxJS, we have the incredibly powerful async pipe. Say you make an HTTP call that returns an observable. Instead of manually subscribing in your component, you just drop the async pipe directly in your HTML template. It automatically subscribes, grabs the latest value, and most importantly, it auto-unsubscribes when the component is destroyed. We are talking zero memory leaks and zero manual teardown. Speaking of teardown, let's contrast the old way with the new way. For the longest time, developers had to rely on the bulky ng-on-destroy lifecycle hook to clean up manual subscriptions. But Angular 16 drops some absolute game changers: destroy rough and the take-until-destroyed operator. These give you a much cleaner auto-unsubscribing setup right inside your constructor, letting you bypass manual ng-on-destroy methods completely. But the absolute biggest leap recently: signals. A signal is a brand new reactive primitive for really fine-grained state management. Instead of traditional change detection that checks the entire component tree, signals literally tell Angular exactly what changed and where. You've got computed to create derived values that update automatically, and effect to run side effects only when specific signals change. It is incredibly precise. Finally, Pillar 6, pipes and optimization. We obviously want our data to look great, but the app still needs to render blazingly fast. Angular uses pipes to transform template data. Now, by default, pipes are pure, meaning they execute only when their input values actually change. Impure pipes? They execute on every single change detection cycle. And this brilliantly illustrates why pure pipes are the default, because impure pipes can completely taint your performance if you aren't super careful. Luckily, Angular packs a ton of built-in pure pipes. You've got date pipe for formatting dates by local rules, currency pipe for handling money. The JSON pipe is a total lifesaver for debugging because it spits objects out as JSON strings right on the screen. And slice pipe quickly carves out subsets of arrays or strings directly inside the template. Before we wrap up, I want to hit you with one final critical optimization question out of the 143 concepts we've been pulling from. It's a classic trap for developers dealing with large lists. What exactly is the track-by function used for in an ng-for loop? Well, this is the absolute secret to high-performance lists. Without track-by, if you update an array, Angular often just destroys all the DOM elements and recreates them entirely from scratch. Talk about a performance killer. By throwing in a track-by function, you're telling Angular to track items by a unique identifier. This vastly improves performance because the framework will only update, add, or remove the specific DOM elements that actually changed. And there you have it. We've just distilled the essence of 143 technical questions into a rapid-fire bootcamp, tracking the framework all the way from basic components to high-level DOM optimization. But remember, Angular is a living, breathing ecosystem. With a big shift away from ng modules towards standalone components, plus the massive addition of signals, the framework is faster and leaner than ever. What we covered today is the bedrock, but the architecture is always shifting. So I'll leave you with this. As Angular evolves, is your mental model keeping up? Keep exploring, keep building, and I will see you in the next explainer.